Okay, hi. Welcome to MinneBar 2020. I'm so glad to be here. First of all, thank you so much for having me, and thank you for joining me. This is wonderful. And this is IoT and JS. This is a gentle introduction to Internet of Things. Oh, it may also have the IoT, the Internet of Toilets bit on there too. It's the same talk. But yeah, that's it. Thanks for having me. All right, let's get into it. I need to do a quick introduction myself. My name is Joe Karlsson. I'm here in Minneapolis, actually, and I work for a little company called MongoDB as a developer advocate and software engineer. I work primarily with Node and JavaScript, both on the front end and on the back end. Love them both. If you want to get a hold of me, or if I inspire you at all in this talk, or if you have any questions, best way to get a hold of me is via Twitter. You can see my Twitter handle there at Joe Karlsson1. I'm also going to plug in for my Twitter, my TikTok. I've been on TikTok a lot recently, and I know I tell engineers that, and they're like, "Are you dancing?" Like sometimes, but I'm mostly just telling software engineering jokes. I post them on my Twitter, but if you're on there, you should for sure check me out. I'm having a ton of fun. For you too, I'm going to be presenting a lot of information, links to resources, coupon codes, links, whatever. You can find all that information on that bit.ly link there on the bottom. bit.il/IoT Litter Box. You can also take a picture of that QR code in the upper right-hand corner. I'll be posting that over and over again, so you can always take a photo of it then. Lastly, I need to cover my ass, so opinions are my own. If I say anything controversial, please don't get me fired. It's me. I'm not. I don't speak for my company. I don't know. I swear a lot, so it's just me. Okay. So I've been doing IoT work for a long time. This is a magic mirror project I've been working on. You can find out more about that there. It's actually one of the most useful projects I've actually ever built as an engineer. And then last, cool little mood light project. It's a little IoT panel that, see, is this going to turn on? Oh, there we go. That shows lights. You can control it from a web app anywhere, which is super cool. There's a little IoT chip in the side of that thing. But anyway, I love building IoT projects. I think it's amazing. Okay, so let's just jump into IoT. Let's start. We're going to be talking about what IoT is. And then I want to talk about JavaScript and IoT and why you should potentially be choosing that for your next application. I also think then we're going to be talking about my IoT kitty litter box. So I love talking about stuff at a high level, but there's a line where we have where like high level abstraction, we needed some concrete code. We'll be using my kitty litter box as kind of a way to dig into a real world IoT project. And then lastly, we're going to wildly speculate about the future of IoT. I think this is helpful, especially for an introduction talk, because it shows you whether this thing is worth your time to learn it all. Is it worth it? I think wildly speculating about the future helps us kind of figure that out. Yeah, but it also helps me figure out if I'm going to embarrass myself too in 5 years for making wildly incorrect tech predictions, which would never happen in tech. Things don't move that quickly. It's a wink, wink. Okay, so first of all, what the heck is IoT? You probably already know this, but it's basically anything with a chip in it. Anything that connects to the internet is part of IoT. Okay, so we know like Fitbits and rings and nests and homes, like we get it. My favorite part about IoT though is actually stuff that you don't see very often in the wild, or you can't buy at Best Buy, and that's like the weird art projects and shitty things. I think the weird line of pure garbage and kind of genius is like my favorite place to live with IoT. It's the Wild West days, baby, right? Like we're trying to figure out what that even looks like. Like, how do we use these things? We're just throwing chips in everything. Some of it's better than others, but I kind of like exploring that. I'm like, what? Let's see where that goes. I'm also interested too in art, like IoT as art. I think there's some interesting implications as an artist for embedding internet connected devices and kind of exploring this new like dimension of art that no one's been capable of before. And I think the people watching this stream right now, we are uniquely positioned to explore this new medium. And how does internet and chips and computers, how can we use that? I don't know. I'm just fascinated by it. And I love that idea. Okay, so IoT, it's anything with chip in it. Okay, great. Piece of cake, easy. Joe likes art. Okay, let's move on. We only got 15 minutes left. This is such a fast little talk here. So, JavaScript and IoT. Why should you be picking that? I don't know. Let's find out. First of all, Node. I'm using Node for my IoT kitty litter box. But did you know that actually 58% of IoT developers self-identify as Node developers? That's a huge chunk. That's a quorum. Is that a quorum? It's over 50%. JavaScript may be a weird choice. I think if you think of JavaScript or as hardware development, you're probably thinking low-level embedded programming languages, something like C or C++. But again, this is a highly personal opinion. I'd argue JavaScript is actually a great choice for new developers. A lot of developers are learning it straight out of boot camps. It's a more friendly language because that's a garbage collector as opposed to languages at like C or C++, where you have to manage memory at a really low level. And I'm not saying that there's not massive benefits to those, because there are. You can do way more. They're way more smaller. They can be more efficient, and they can handle memory much better than JavaScript can, because they don't have to worry about garbage collection. But if you're just like jumping into it, why learn everything new? Just use what you know. That's how I jumped into it. Easy to update over network. A lot of times with embedded languages, you actually need to get that chip again, plug it in, reflash it with the new code. JavaScript's easy. All you have to do is run a git pull and an npm install, and boom, your entire fleet's been upgraded. Done. Easy. Super easy. And Internet already speaks JavaScript. Let's just keep going. What's wrong with that? You may also not know this either, but there's actually there's a huge thriving ecosystem for IoT projects. The two biggies today are Cylon.js and Johnny 5. I'm going to be using Johnny 5 for all of the work I've done. I think it's great. I've had a lot of fun with it. I'd recommend checking that out as well. But there's a bunch of others, so you can totally check out. Lastly, I think from an architectural perspective, JavaScript already is event-driven. Node is a callback-driven language. And even on the front end, when we have things like a user click event in the front end, that's an event, right? We have a callback function, a native. That's how it's built. JavaScript is great at handling asynchronous events. And if you think about IoT projects, it's all event-driven. So we're waiting for a light sensor to detect a certain degree of like lumens coming in, or a moisture sensor degree, certain thing, right? We're waiting for this event to happen on a piece of hardware, and it triggers a callback function we can do something with. It's the same. It's how we're building our applications already. It makes so much sense to build it with event-driven like programming language like JavaScript or Node. Okay, that was the super fast version. We got 12 minutes left. I want to talk about my litter box, and because I think it's helpful for us to jump into something that's like practical and real. So, what does my litter box actually look like? This is it. I sprang for a little fancy little mid-century modern piece, but it looks great, I think. You could use a cheap plastic one. You can see a little cable popping out the back. That's where you plug it all in. There's also a little slot to the left that has all the electronics saved in it, which isn't much, but it hides it away a little bit. So I built this kind of as a joke. I'm obsessed with these shitty ideas. I actually ran a hackathon in Honolulu, Hawaii. It's a stupid shit and terrible ideas that no one needs hackathon. And we just built things that people need just for the sake of making them. I feel strongly about just making stupid stuff without like money without money or a purpose or reason. And it was just a chance to build it with friends. Anyways, I'm obsessed with this idea. But I started building it and I did some homework, and it turns out it may actually not be a bad idea. Wired reviewed this Litter Robot 3 Connect. It's they gave it an 8 out of 10, and it costs $500. I could start making this shit. I can make this. It's a thing though. I think it's a thing. And what does it do? The most important thing that it does is it passively measures my cat's weight. Every single time he enters the box, I take a passive measurement of how much he weighs, and I record when he goes to the bathroom. I'm also recording events like every time the box gets cleaned. But let's get into it actually. So we have our box. Again, this is like a cheap one. You could totally use this. I have that fancy one with that sliding door. But when I remove that door or open it up, it goes into maintenance mode. Maintenance mode basically means I'm either adding or removing litter from the box. When I put that box back on, it means that I'm done cleaning it. And what I do is I initialize a base weight for the box. The box then just sits and waits. It just waits for an event to happen. And I'm waiting for a cat-sized object to enter that box. And then I want to do something with it. So it's waiting for that. It's just cat size. I don't know if it's actually cat. It could be a raccoon. It could be a possum, a toddler. I don't know. It's just got to be cat size. So it's waiting for this thing to enter the box. And once it sees a cat-sized object, that's a bathroom event. So I wait for him to chill out for a little bit, to scratch, whatever. I wait like 30 seconds. Then I take a measurement of how much he weighs, and I send that to the cloud. I measure that, boom, save that. If the cat leaves the box, you may have added additional weight to it, so I reinitialize a new weight after a certain amount of time has passed, like 2 minutes. I wait for it to kind of chill, and then I take a new base weight for the box, and then we just wait for that new event to happen again. It's pretty simple. It's actually pretty simple. If you want to follow along with this code, again, you can check out that bit.ly link, bit.ly, yes, IoT Kitty Litter Box. As all the source code, you could totally check that out there if you want to follow along. But this is a gentle introduction now. So I'm just going to be showing you enough code to kind of jump in a little bit, make it real, and then we'll kind of see what happens from there. So if you're getting into your first IoT project, this is my this is me recording me actually building the box from scratch. But the first step for any IoT project, the hello world, if you will, is to make an LED blink. It basically means that you've initialized the board correctly, and you can have the most simple circuit be working. So you can actually see that LED blinking off and on off of my Pi that I'm using. I picked all these supplies up on Amazon for like 45 bucks. They're all pretty cheap. You can get like a pack these days for like an IoT pack or whatever. But what does that code actually look like? So again, I'm using Johnny 5, and Johnny 5 works on a ton of different boards, but you need to basically initialize it by saying, hey, Johnny 5, you're going to be talking to a Raspberry Pi board. So cool. We bring in the Raspberry Pi package, we bring in Johnny 5, and we initialize that brand new board and say, hey, we got a brand new Raspberry Pi board. Great. Johnny 5 now knows how to talk to that board. And we already talked about those callback functions, right? So we have when that board is ready to start listening for events in the real world, I'm basically we have a LED light on the P113. I had to look that up. I have no idea, but it basically means it's on the 13th GPIO pin, which we don't have time to talk about today. But totally message me if you want to have questions about the GPIO. And then Johnny 5 is so amazing because it has built-in functions that integrate with a bunch of existing sensors and hardware. So we just tell that, hey, there's an LED on this pin, just blink, and that's it. That's hello world. Done. You're done. Okay, so a blinking LED does not make a toilet. I feel like there's a poetic way to say that, but so let's actually make a toilet. Let's make a cat toilet. Put the T in IoT, toilet. So I got my board, we initialized it, great. This is the interesting part though. So we're on board ready. Instead of an LED, all we're using is a switch. So I'm using a magnetic switch to sense when that door opens and closes. And we basically just alter the state of the application to be either in maintenance mode or not. We can do things based on that. You can actually see here, I have a little demo here. It's a poorly shot video, but I have that door there. You can see that little magnetic switch. I'm opening and closing it. And you can see on the console log on my computer, the events being triggered from that piece of hardware. So every time I open that door, it can tell whether it's been open or closed, and we can put it in maintenance mode and do whatever we want with that information. Okay, the fun part, the load cells. Think of load cells basically as an internet-connected bathroom scale. I had some work with it that didn't actually work with this thing, and I had to do some fancy stuff. And the fun part is I got to actually use the spawn child process, which was a blast to use. So I'm actually using I found a Python library that can use these load cells I figured out. And I'm just spawning a separate thread that runs a Python script in the background that's taking measurements from these load cells. If you ever use it before, this is actually what it looks like. It's just a callback function that's waiting for data to come through from this separate spawn process from Python. And then I basically update the weight after that. You can handle errors and when it gets closed or whatever too, but it's just super easy. It was a way more elegant solution, and I had so much fun building this. I learned a ton. Okay, so what does that actually look like? So that little piece of plywood, that's actually the bathroom scales underneath of that. You can see here, it's just reading it every 10th of a second. It's taking a measurement. So I'm pressing on it. You can't see it actually on the computer. Too close, pressing on it. You can see it actually being registering the weight as I press down on that piece of plywood. There we go. Now you can kind of see it. Okay. Oh my gosh, we have 5 minutes left. This is so tight. I work for MongoDB, so I'd be remiss not to talk about data at least a little bit. So here we go. Schema series design. I'm saving this data in the cloud, and I'm using a IoT schema, which I think is amazing and native and works great for MongoDB. I'm going to say MongoDB makes a great choice for IoT projects if you're persisting data, and this is why. Most of us are using like a report to get that data off of. I'm showing charts, showing like daily activity for it. So every day I have a brand new document that gets created. I have some metadata about that. But if you see there, I have an array of events. And every single time either a maintenance event happens or a bathroom event happens, I'm just pushing a brand new event object to that event. And I can do super amazing queries, do some amazing charting on that. It's great. But it's super flexible for how we do that. Another huge thing we can do too, I added additional sensors to this box and I was able to update the schema super easily. Having a flexible schema is super huge for IoT data because it works super well. I don't really give a shit about all my old data not being updated with this new sensor data because it didn't exist. But I care about new data, and it was super easy to do that with MongoDB databases. All right. I do want to show the final box assembly here. You can see the Pi kind of screwed to the base of the board. I can screw it all in. You can see all the wires and everything. And then I'm plugging it in. Whoop, and that's it. Right? It all hides away. I think it looks great, but I'm biased. It's up to you. You can judge. You can judge. You can judge. You can judge. You can judge it. And that's my cat using afterward. He actually uses it every day. It's great. I'd say it's been helpful. Okay, 5 minutes left. We got the future of IoT. What does that mean? Where's this going? Is this important? I don't know. So I predict in the future that we're going to continue to see smaller and more powerful devices. Duh. We're going to see smaller sensors. We're going to see more integrated stuff. We're going to see IoT stuff. We're already seeing like built into clothing and shoes and watches and whatever, right? Like we're seeing it integrate in classes. I don't think that trend's going to stop anytime soon. I think we're going to continue to see super tiny embedded devices show up in more and more and more places. I think we're going to see JavaScript even show up with smaller footprints. Like JavaScript isn't designed for hardware. It works on it because we can run JavaScript runtimes on these small chips these days because they're so powerful. But I wouldn't be surprised if we even start seeing some JavaScript runtimes designed to run a more slimmed down, kind of like a Raspbian for JavaScript. You know what I mean? Like a stripped down version of Linux or a stripped down version of JavaScript to make sure that we can run that code. We're going to continue to see better hardware support, more sensors and chips supported by JavaScript. And this is true for so many things, but batteries will continue to be the bottleneck for our applications. We're seeing that, like, especially for like things out in the field, having a small device, and if it runs like it's a really powerful chip, it's going to take a lot of energy, and that's still a bottleneck for our applications and our phones in general. Like it's a bottleneck for everything right now. But it'll be interesting to see if there's any new battery innovations that happen in the next couple of years. Okay, we got to wrap up here. So what did we talk about today? We gave a brief introduction of IoT. It's basically anything with a chip in it. And IoT is exploding. We missed that for this talk, but it is. Take my word for it. And then we talked about JavaScript and IoT. Did you know that 58% of JavaScript or IoT developers self-identify as no developers? You do know. JavaScript's great for new devs. Personal opinion, but I think it's much easier to handle, right? Easy to update over a network. You can just do a git pull, npm install, boom, you updated. And it already speaks JavaScript. Why change? Why change? It already works. And there's tons of great existing libraries. And lastly, we talked about event-driven architectures, how that works super well with JavaScript and IoT projects. All right, then we talked about my real-world kitty litter box I've been building. We talked about the hello world and just getting the LED to blink. Cool. We talked about the switches and load cells, how to get those working. And then lastly, we talked about the future of IoT. And we talked about how they are getting smaller and more powerful. We talked about how JavaScript is going to continue to get a smaller footprint and be more efficient. We talked about better hardware support for JavaScript libraries on IoT and how batteries are going to continue to be the bottleneck as we build applications in the future. Oh, boy. All right, we got a minute left here. So if I've inspired you all to want to build an IoT project sometime in the future, how do you do that? I think you just got to do it. Pick out something stupid, make an LED blink, get some stuff, like buy a IoT starter kit and Raspberry Pi on Amazon and just try to make it. I'd recommend Raspberry Pis for your first project because they're super easy to run, super easy to build, they're cheap, and you don't have to learn a new language. And if you mess up, you can just clear it and rerun it, and it's got like a Linux-like or a light Linux runtime on there, which I've had to use to like troubleshoot stuff, which is really handy. If you have questions, obviously this is pre-recorded right now, so hit me up on Twitter. That's a great place to hit me up too. But I just want to say thank you for having me. This has been a total blast. I'm honored to be here, and I'm obsessed with where the Minneapolis technical market's going to. All the resources can be found there, and if you think I'm fun and want to keep hanging out with me, for sure follow me on Twitter, Twitch, TikTok, my website, whatever. Just like come hang out with me. I'd love to just hang out with you in the future. I'd love to see you. All right. That's it. Thank you so much. Bye.